In our first lesson of Foundations 1, we're going to define, draw, recognize, and correctly annotate points, lines, line segments, rays, planes, angles, coplanar points, and collinear points. So lots of vocab. And you'll also be able to recognize and label congruent line segments. So points are really just the most basic building block of geometry. It has a location. I can tell you where it is, but you can't measure a point. There's absolutely no length, width, or depth. So really, if we're thinking in dimensions, there's 0 dimensions. There's nothing there to measure. When we talk about points, we literally say the word point and then whatever letter we associate with that point. So point A, for example. But when I write about it, I don't need to write the word point. I can just write my capital letter A. When I draw it, even though there's no actual dimension to the point, we go ahead and draw a tiny dot there to show where that location is. I think of it as like seeds in a fruit. So there's all sorts of points scattered throughout the flesh of the fruit, some closer, some farther, some in a row, some in a straight line, some not, each one of those being a point. If I take up a whole bunch of points and I load them all out into a row forever and ever and ever, that makes up a line. So a line is a bunch of points strung together like beads on a necklace. It has direction and length, but there's no depth or width. So I can measure how long a line is. Well, the answer is infinitely long, but it's got that one-dimensional measurement. There's no depth or width. I can't find the area or the volume of a line. I'm going to name it using any 2 points that are on the line. When I talk out loud about it, I'm going to say line XY and then write XY with the little line. It's super important that I have these tiny arrows up above those 2 letters to show that, hey, this is a line and it continues forever. When I draw it, I have my line, my points are marked on there. If I had a third point, like Z, I could also name this line XZ because I can choose any 2 I want. And I can also reverse those. So I could do YX, or I could do YZ, or ZY, or ZX, any combination of those. Those are all the same line. You're talking about the whole thing, as long as I've got the arrows on either end up above. Every once in a while, you'll see this in textbooks or on standardized tests, where instead they're naming it with one lowercase cursive letter. So maybe I have line Z. When I write it, though, they used a cursive letter here, and then that cursive letter is hanging out here. Z isn't a point on the line. They're just naming the whole line rather than marking any points. If I take just part of a line, I get a line segment. Okay? It is not infinite. It has 2 endpoints, and I have to name it using those endpoints, even if there's a third point in between. Okay. I say the words line segment and then the 2 endpoints. I write the 2 endpoints, and then I have a little baby line segment up above. I can reverse those letters, so I could have CD or line segment DC, but I can't use CE, because if I say line segment CE, that implies just that much, not the whole thing. The biggest difference is that a line is infinite and has arrows on the end to show that it's infinite. And because it's infinite, I can pick any 2 points when I want. Line segments are just part of the length. There's no arrows on the end, and you have to use the endpoints even if there's other points on that line segment. A line segment is kind of like a piece of spaghetti. A line is going to be like an infinite spaghetto, which is one giant spaghetti. Looking at our examples, that very first line, I have P and U on my line. I can name it as line PU with the little baby line up above. Notice I included the arrows to show it goes on forever. Or I can do UP on the, if I flip those points. Those are the only 2 points on that line though, so I have to use those 2 letters. On example 2, looking at this line, I have 3 letters. I can pick any 2. I don't get to pick 3, but because I can pick any 2 I want and put them in whatever order I want, these are my 6 options for naming it. And then I have a line segment, and I know it's a line segment, first of all, because it says line segment here. Second of all, because there's no arrows on the ends. I have to use my endpoints then, G and B, so I can do line segment GB or line segment BG. And notice just like there's no arrows on my picture of a line over here, I'm also not putting any arrows on my markings above my letters over here. If I take a whole bunch of lines and I lay them right next to each other, I get a plane. So a plane is going to have length and width, but there's absolutely no depth to it. And just like my line, it extends infinitely. We're going to mark one cursive letter in the corner, and we're going to use a capital this time. We say the word plane M, we usually write the word plane and then the capital, and when we draw it, we usually have some sort of rectangular outline, even though it extends infinitely, and then a cursive letter in the corner. I think of planes like infinite tortillas, that they would extend forever and ever and ever, but they're so thin you can't measure that depth at all. Collinear is just any points that are on the same line. Co meaning together, my co-workers are people I work together with. Line, of course, coming from the word line. Coplanar then are going to be points on the same plane. Again, co plus plane gives us coplanar. They don't necessarily have to be collinear. I could have a plane that looks like this. These three are collinear, and they're collinear because I drew the line in. And then I've got another point out here that's not on the line, but it's on the same plane as them. When I look at my example, R, O, and S are all on the same line. Sometimes kids are like, well, couldn't I make R and I collinear? And you could, but they didn't draw the line for us, so we're not going to count that as collinear. R, O, S, I, and E are all coplanar because they're all laying on the same plane. Only R, O, and S are both, right? It was on the same line here, and it's on the same plane here. Then we're asked to think about, hey, can points be coplanar but not collinear? Absolutely. We can see I and E with R, O, and S. We're coplanar with them but not collinear. And then can they be collinear but not coplanar? The answer is yes, but that's rare. Think of like if I had a plane going kind of like up and down, and I had a line here. Cool. And then I went from this point and I came like out of the plane. Like 90 degrees to the plane, and it's going like through the plane kind of thing, and then it keeps going up back here. This point and this point are collinear, but they're not on the same plane. We don't really do this in 8th grade geometry though, so don't stress too much about that. All right, my midpoint is going to be in the middle of any line segment, and it's always equidistant, which is a fancy way to say equal distance from both endpoints. I mark that with these little tick marks, just like I did here. That shows, hey, AB is congruent to BC. If I had a second line segment, and I wanted to show DE was congruent to EF, I would use 2 tick marks now because I already used one up here. And it's really, really clear to us that DE is not the same length as BC, so I don't want to accidentally convince someone of that. A ray is going to have one endpoint and then extend infinitely in one direction. So it's kind of like if a line and a line segment had a baby, where a line segment had 2 endpoints, a line kept going in both directions, a ray gets one of each. We're going to say the word ray and then the endpoint. So in this case, it has to be R, and then any other point. When I write it, I always put the endpoint first and then any other letter. And then I draw a little baby ray up above it. If I had a second letter on here, I could also call this ray RA, but R has to come first. So in a ray, I can't reverse those letters. It has to be the endpoint first. Looking at my examples, the only way to name that first ray is ray PU. Notice I had my little baby ray up above. In example 8, D has to come first, So I can either name this as DI or DN, but either way my endpoint D has to come first, and then I have a little baby ray up above. In example 9, sometimes kids are like, oh, the endpoint's over here and it's pointing towards the left, so I'm going to name it like this and have my ray going that way. But we don't do that because the English language doesn't read that direction, and so it gets really confusing. Okay, your endpoint still goes first on the left, and then on the right you've got any other point, and your ray still points to the right. If I take two rays and I have them hot glued together and they share an endpoint, I get an angle. I could name this angle ABC, so I'm starting at one of my points on a leg, going to my vertex, the shared endpoint, turning and going to C. Or I could go the other way. I could go C over to B, turn, go to A. So angle ABC, angle CBA. Notice my vertex is in the middle when I name those, that shared point. I can also call it angle B because this is a special case, and we'll talk about that more in a second. Or because I wrote the number 2 in the picture, I can call it angle 2. Okay. If I didn't write that in the picture though, I have no idea which one's angle 2. There's no letters there to imply that angle 2 is the specific angle. So it has to be in my picture, or I have to be able to add it to it because it's on paper and I have a pencil in order to do that shortcut. I can only do angle B here because there's only one angle at angle B. If I had an angle that looked like this, and I tried calling it angle B, well, you don't know if I'm talking about this angle, or this angle. So in that case, I have to use numbers or 3 letters. And add in some letters here to clarify which one I'm talking about. So you can only use the single letter if there's exactly one angle there. Congruent means something that's the same shape and the same size, and we only use it for objects. So my right hand is congruent to my left hand. Triangles can be congruent to each other. Circles with the same radius will be congruent. And I can say something like AB is congruent to CD. AB is a line segment, so I had the little baby line segment up above and the congruent sign in between. Equal is used when I have magnitude or value, and I only use it for numbers. So we're used to doing something like 7 equals x plus 3. But now we could also do something like AB, and this time I'm not using the line segment up above because without it, it means the length of AB equals 7 centimeters. Or I could do something like the measure of angle A equals 90 degrees. I have to have some numbers involved though to use equal in geometry. So again, congruent is going to be used for line segments, angles, polygons. Equal is going to be used for numbers, measurements, values, variables.